Hello, I'm Kathleen, and we're going to be talking about the labs for this week, which are on fluids. So we are going to be looking at different labs that have to do with different types of densities, viscosity, other fluids, the non-Newtonian fluids that are super fun, and even Bernoulli's principle. So please stay tuned as we look at fluids. So this is density lab number 1, and in this lab we're going to look at the different densities of liquids and how they're changing when you put food coloring and Alka-Seltzer tablets into the jar. So we filled the jar 2/3 of the way with the oil, and then we're going to fill it the rest of the way with just some water I measured out in advance. And so it's important to note that liquids fill the shape of a container you pour it in, and this is seen when we're pouring this into the mason jar. So water is notoriously having a different viscosity and density than the food coloring and the oil, so that is seen here. So as you can see right now, I'm putting some blue food coloring into the bottom of this, or sinking to the bottom as we go. And so the bubbles of the colored oil, the food coloring created, will eventually rise to the top when we put the Alka-Seltzer tablets in. So I'm just about to add a few more drops of food coloring, and some liquids have atoms and molecules that are packed tighter together than others, and this is going to be displayed here. So once we drop that tablet in, as you can see, the water and the CO2 are reacting to create the bubbles. And so you can see I'm kind of rising to the top, and I'm waiting for this reaction to kind of slow down a little bit and to stop so I can add a second one as the instructions said to do. And so you can see that some of the food coloring is coming to the top, and there's definitely a reaction occurring here. So as this continues, I'm just carefully watching it and waiting for something else to happen. And notice that it does not bubble over, which was a nice surprise, as I was a little worried that was going to happen. But it's bubbling to the top, and we see it kind of starting to slow down, and the Alka-Seltzer tablet just went to the top. So we're getting towards the end of the first reaction to occur. And I just used vegetable oil for this and found that it worked really well. And now you can see kind of a split in the colors between the oil and the blue at the bottom. So now I'm going to take that second tablet in a second or two and drop it in right when I'm ready. Okay, so this is the second density lab we're going to look at this week, and you can see I have purple colored honey at the bottom, which is the most dense of the liquids in this experiment. So I already made that purple, and I stuck it in the bottom, making sure to pour it where it didn't get on the sides too much. So the next liquid I'm about to pour, as you can see right here, is the blue dish soap. So I'm going to measure out a 1/4 cup of that. And it's important to note that density is mass over volume, and if the mass increases but the volume stays the same, then the density increases. Vice versa, if the mass decreases but the volume stays the same, then the density decreases. So as you can see, I'm carefully pouring in the blue just dish soap into the jar, trying to make sure that it does not mix, and it kind of, you can see really well that it just kind of goes on top of that, creating almost the beginning of a rainbow. In the end, we'll have a bunch of rainbow colors in there, so I'm just going to make sure that it's completely scraped out. And then it's important to note that lighter liquids are less dense than the heavier liquids, which is seen in this experiment. We can already tell that the blue dish soap is already lighter than the purple honey, and we made the honey purple just so it would not look the same as the olive oil that we'll eventually be putting in there. So I pre-measured some water, and I put some green food coloring into it, so we can see the difference in the density and almost create that rainbow-like effect. So all liquids have their own unique density. That's really important to remember here. And we can see I'm putting the green food coloring in, mixing that up, making sure it's really together. And I'm going to put this on top of the blue dish soap to see if it is lighter, which it is, or less dense at least. So the lighter liquids are obviously going to float to the top, whereas the heavier ones. And I found this experiment really interesting because yes, I knew that they had different densities, but I'd never actually put it in side by side to see. So yeah, so we're going to mix that up. It took me a little while to get it mixed. Sorry about that. So I just want to make sure all the food coloring was in so you could really see the bright green color and tell the difference. So I'm going to just kind of mix that up, double check it, and then I'm going to just about in a second or two pour it in there, carefully making sure that it does not mix with the blue dish soap or even the honey by chance. And I think I, for the most part, did a pretty decent job trying to tilt the jar but make sure the liquids don't mix. So it looked really pretty. I don't know how well we'll be able to see it in the video, but in person you can kind of see the layers. So there I am checking the layers to make sure. And yeah, so the next liquid we're gonna do, I'm gonna get that ready. So that's the olive oil. That one's pretty easy. I think I used a smaller measuring cup. I used an 1/8 measurer because I was running out of 4ths, but I did it twice. So I made sure to slowly pour that in there and just get it where it would cover the green liquid completely. So we're seeing that olive oil is less dense than water, which is less dense than blue dish soap, which is less dense than the honey that we colored purple. So there's the first olive oil in there, and it's kind of hard to see when we did the first one just because it was so small. It was such a small amount, but you can see a little bit of the yellow. And then I added a second one just to make sure that I completely covered it. And we can see that within this experiment that mass is decreasing as we continue to put in more liquids. Therefore, the volume is staying constant because we're keeping it in the same container. So the density is decreasing. So there's all our olive oil in there. It's looking a lot, you can definitely see the olive oil in comparison to the other ones. It kind of looks dark, but trust me, when it was light in the kitchen when I was doing this, you could definitely tell. So I'm rinsing that out. And then the next liquid I'm going to get is my rubbing alcohol, which I'm going to use red food coloring in, which might take a while to mix it in. But I'm going to use my red food coloring to make sure I can see the difference because rubbing alcohol is normally a clear color, if that even counts as a color. So we're going to see once I wash this. I'm going to get my rubbing alcohol. So, sorry that took me a second. I was measuring out my rubbing alcohol. So I'm going to move the olive oil and I'm going to get my spoon and some red food coloring because I really need to make this pop. So there's my rubbing alcohol. And I just got, it was labeled alcohol for rubbing at the store. And it was very pungent to say the least because it's rubbing alcohol. So I was really interested. I kind of knew at this point that it wasn't going to be denser just because of the order we had been doing it. I could see the pattern, but I was a little interested to see what would happen. So I'm going to take my red food coloring, and I used the gel food coloring for these experiments, so it took a little bit longer to mix it in and truly make it look like one thing because it kind of looked pink at first until I kept stirring. So we can see this experiment is very interesting compared to the last one because they're both looking at densities, except this time we're comparing densities of different liquids. And I also thought it was really interesting because all the liquids are pretty much everyday things that we had in our kitchen. So I never really thought to compare that. But yes, here I am mixing the red, and it looks kind of like Kool-Aid. But I'm going to pour that into the jar, which I think was just a vase that I found in my house. So it took me a little while to mix it, as I said, because it was the gel one, and I didn't want little bits of red gel floating in my jar. So I mixed that pretty well, and then I poured that on top, and then it spilled a little bit, but it was okay, and made sure that didn't mix. So there's that. Okay, so this is our viscosity lab. I had a lot of fun with this lab because I got to do multiple trials of dropping a marble into a fluid to see how long it took. And at the end of this lab, there will be a little clip of my chart. So I started with water because that was the first one and seemed the easiest. And I marked on the glass with 2 pieces of masking tape just so I didn't write on the glass because it's my mom's dishes. So I dropped the marble in, watching it start to finish, using a spoon to scoop it out, just because when it came to the more viscous liquids, I didn't want to stick my hand in syrup. So viscosity is the quantity that describes fluid's resistance to flow. So as we can see within the water example, there's not a lot of resistance with the marble. It goes very quickly. And when looking at my numbers, it was so fast. I had to hit start, stop really fast. So I did 3 trials of each. And it's important to note that fluids resist relative motion of immersed objects through them, as well as motion of layers with different velocities in them. So as the experiment continues, we can see that. So here's the next one. This is the oil. And granted, it took a little longer for the marble to go in. And I wiped the marble off each time because I only had 1 marble. Don't have a lot of marbles and they're hard to find. But so I did a few time trials of this, and granted it was a little slower than the water, but it really wasn't by much. I still had to hit start stop very fast. As you can see, it's happening really quickly. So granted, the viscosity is a little higher because the time increased, but it's still not super high compared to other liquids or fluids that we'll be using in these experiments. So here's the 3rd trial, start stop. It was very fast. Like I said, not as fast as water, but faster than some of the other fluids that we'll be using for these videos. So the next one is going to be the syrup. And so it's important to note also that viscosity is officially the ratio of the shearing stress to the velocity gradient in fluid. So this one's kind of harder to see just because it is maple syrup. And it's important to note that I chose this container because it was one of the smaller glasses we had, but it wasn't so small that I couldn't get at least a comparison in the start and stop time. So with maple syrup, as you can tell, it is a little more viscous than the past 2 fluids. It still moved very quickly through the maple syrup, which I think was the thing that surprised me the most, just because you expect maple syrup is so sticky. I was wondering if that was going to have an impact on it, but it didn't really do so. So it's important to note also, there's a lot of important things that there's certain types of viscosity. So there's dynamic viscosity, absolute viscosity, simple viscosity, and then kinematic viscosity. And as you can see here, we're testing the viscosity of honey, which I had to get a lot of honey for. And this one didn't surprise me at all. It had a very high viscosity. And so the marble it looked like it was falling in slow motion. It's also kind of hard to see, but you can still see a little better than the maple syrup. So you can see I had to wipe off the spoon, try to get it all out of there because it was so viscous. But there's that. So yeah, the marble took a lot longer to measure the time because if you watch this, I dropped it and then it's slowly falling there. So we can definitely tell that there's a lot of resistance to the flow in this example here, and the marble took a while to get to the bottom of the glass. And like I said, the glass was still pretty good sized, even though I didn't want to fill up that whole jar I used for the last experiment with honey, because that's a lot of honey and I don't know if there's that many bees. No, but so I'm gonna do my 3rd time trial, and I wiped it off some. I definitely cleaned the marbles between each trial with each different fluid, but I wiped it off some on the spoon, and then I got ready for my 3rd time trial of this, and my hands are really sticky at this point, as expected, but so there's the 3rd one, and it's going to the bottom, and it's it looked like it was moving in slow motion, especially compared to the water. And then here are our results for the final time trials. So now we're on to the non-Newtonian fluid lab. I had a lot of fun with this lab. It did feel kind of icky to touch it in the end, but it was very fun to do. So I have done this before, actually, when I was learning about colloids in elementary school, sometime after school. So colloids have very strange behaviors. So the tiny solid cornstarch particles are suspended in the water once we're dumping some water in. The experiment called for me to slowly mix in a half cup of water, so I kind of did that, just making sure I got it all up. And I eventually put a little bit more cornstarch into the mixture or solution because I just wanted to make sure it had the texture I wanted. It was a little liquidy in the end, but I put in a few drops of green food coloring to make sure it had a fun color because the experiment instructions suggested that. And so it's important to note that the qualities that were created with this lab, I think we made oobleck was what it was called. So Newton came up with some what he called ideal fluids, and they were Newtonian fluids, and they had certain principles. And this specific fluid does not have those principles. So cornstarch specifically is the reason it doesn't act like this. So the scientific term for non-Newtonian fluid is thixotropic. I think I said that correctly. And other examples of non-Newtonian fluids are ketchup and quicksand, which resembled this. And so I'm scraping the bottom, just trying to get it all up here. So I can see that as this is happening, it's getting kind of liquidy, but I recognize, since I've done this before, I recognize that the texture was supposed to be a certain way. So I'm mixing that up. And then I kind of just started doing it with my hands, and I'm dumping the rest of the water in because it was easier just to get in there and use my hands. So it's really an interesting feeling because if you quickly poke it or tap it or squeeze it even, it feels like a solid. It's as simple as that. But then if you're slowly stirring it or letting it drip out of your hand, it acts very much like a liquid. You can see I'm kind of getting the rest of it up, but it's really stretchy if you do it a certain way. And this is because the cornstarch behavior relates to its viscosity, which changes, unlike the water that is seen to have an ideal quality of Newtonian fluid. So I'm just making sure it's all mixed. I use the scraper and my hands just because I wanted to make sure I got all the cornstarch up. So as you can see, I am going to add a little more cornstarch. Just make sure I got that in. And yeah, so there we go. And I tried to make a ball with it at one point. And it was really interesting because like the second I stopped trying to form the ball, it just melted out of my fingers. So there's that. I'm squeezing it. Yeah, there's the ball. And then it just kind of drips out of my hand, which is really interesting to me. And I put a plastic spoon on it, and that was really interesting to see how that reacted too. So here you can see it's a very simple mixture of cornstarch and water and food coloring. Who would have thought I would have made something so interesting like this? So there's the solid, but then I kind of let it drip out of my fingers, which was really, really fun to play with, actually. I think this is something I would do with my friends, actually. So there it is. I'm just kind of lifting my fingers slowly out of the mixture. I kind of shook the bowl there, and then like really quickly, and you can see how the fluid acts very differently than water would. If I lifted my hand out quickly or slowly with water, it would be the same speed. So that was really interesting just to mess around with this fluid and see what happens next. So as you can see, I'm still kind of mixing it around, playing with it. I kind of played with it longer than I care to admit. So I poked that, and yeah, it was really fun. It was a really fun lab. And I'm a big ketchup fan, so I didn't realize that ketchup was such a non-Newtonian fluid, but now that I think about it, it makes sense. So there I am making the ball. It wasn't the best ball. It wasn't the most successful one. Maybe it would differ if my ratio was a little different within this lab of cornstarch. I'm kind of curious to see what would happen if you mixed cornstarch and water in different ratios, if it would still create this kind of non-Newtonian fluid. So yeah, my hands were very sticky by the end, just covered with stuff, but there's my spoon, and I'm going to stick it in and just see what happens with that. So I had to kind of do some maneuvering with that spoon, get it in there, and then I had a lot of fun with this lab. Yeah, so once I was done with this lab, I kind of messed with this still a little bit more, put a little smaller spoon. I also really wanted to demonstrate how poking it really slowly made a difference versus poking it quickly. And then I did the final lab, which was Bernoulli's principle, with the ping pong ball floating over the hairdryer. And it was really interesting because the object will fly up at a high speed source until it reaches the point where the force of gravity pushing down is equal to the force of air pushing up on it, which was displayed here. And there was a low pressure air column, which let the object differ from the high pressure around it. I hope you enjoyed the labs we just completed on fluids. We got to see the different densities of different fluids, make our own lava lamp of sorts, see how fluids react with an ordinary hairdryer, as you saw with Bernoulli's principle, and non-Newtonian fluids, which are just super fun to make and explore. And then viscosity, learned a lot about that, how different fluids have different viscosities and densities. So thank you. Have a good one.